Okay, so previously I was talking about Huffman codes and I got kind of confused about this part, but actually it's not that confusing. So I just wanted to have this graph from the README file from the homework to sort of compare what's being said in these notes. So we're going to be creating nodes, right? So this S is the symbol and the F is the frequency. And we're going to be inserting these all into a priority queue. So imagine, like, let's look at this picture right over here. You see we've gotten S, D, B, O, L, F, E, K, W, and A, right? So these are all the letters we read in from some file. Actually, this right up here would be the file that we read. So we have a frequency of each of these different letters. So we create these nodes that have their frequency and then the symbol, and they're all leaf nodes, right? So we're going to be inserting all of these into a priority queue. And we say the high priority equals the low value in this case. And you can kind of see why, like, because these are the low priority, like these are the high priority, these should be dealt with first, because if we deal with these first, they're going to be more deeper into the tree, because you see F is only 1. So we think that F is going to be less common than, say, S. So we're going to have to make it a longer number. We're going to create a longer code to represent F because it comes up less often, so we can afford to make it a little bit longer. So let's see. So high priority equals low value in this case. So the process is we extract the two highest priority, lowest weight nodes. We take them out of the queue. So, so remember, from a queue, the queue is just that we can extract from the front. Like that's basically how a queue works. Is we take things out of the front. So we take these two out of the queue, right? We take F and E out of the queue, and then we create a new node with weight W plus W prime having SW and SW prime as children. So we create a new node with weight W plus W. So we create a new node with weight 1 plus 2, and that makes it 3. And then we make that as children, and then we insert this back into the priority queue. So we're going to insert back. Right, here's the thing: we take these away, right? These are no longer part of it, and then we insert 3 into the queue. So we're basically deleting 2 things, and we're inserting 1 thing. All right, so that's important to understand. And then we repeat step 1, and we're going to keep doing that. And like you see next, maybe either this 2 and this 3 will be in the front of the queue. And then we'll take rid of them and put 5, and then after that you see this 3 right here, this one that we made a combination of the 2 is going to be in the front with this one, and we're going to add them together, and then we're going to get 6, and so on and so forth. So you can see that, like, this is how a queue would work, and I guess maybe I'll try to get more detailed about it later if I can. But we'll look through this example now on the left of an example from the notes. So right here, we have A4, B7, C12, D41. So these are the same sort of thing. Like, this is a frequency. So now we have our queue, and so we have our queue right here, and then we're going to extract 1 and 4 because they're the highest priority, lowest value, and we take them out, and then we're going to put 5 into the queue like this. Okay, we put 5 back into the queue, and then we're going to take the 5 and the 7, right? So the 5 and the 7 are the smallest, and we're going to take them out and combine them together, and then they become 12, and we put 12 back into the queue. So you see we have it like this. Then we're going to combine the 12 and the 12. We're going to take them out, and then we're going to put back the 24 into the queue, right? You see how it goes in here. So then we're going to have 21 and 24, and then we're going to have 41. And then we're going to compare these two, and we're going to take 21 and 24. We get 45, and we have 45 and 41, and we combine them together. 41 and 45, and then we get 86. And you see how we have this thing right here, right? So then we have this tree-like structure right here. And so that's how we use a queue. Now, I know you guys probably think that I haven't explained fully how the whole the heaps, the heapify, and the build heap and all that kind of stuff has to do with this. But I think that I'm going to just make another video and explain like how it looks like in the code, because maybe that will be the most helpful. And I think that now you have an understanding of how like heaps work, like heapify up, heapify down, insert, delete, how the Huffman tree looks, and a little bit about how a priority queue works. So with this, there's two functions in the code. There's PQ push and PQ pop. So when we're doing the PQ pop, taking the two off, and then PQ push, we're putting one back in. So so the next video, I'm going to go through the code and explain to you how it all works together, and then hopefully you'll understand this whole thing a little bit better. All right.